Water. Water is plentiful. Expensive? No, water is cheap. Think about it. 97% of the world's water is unfit for human consumption. The demand for fresh water today is outstripping supply. When demand exceeds supply, goods become more and more expensive. The world is getting thirstier every day, and unless we start saving water now, we may find the well dry tomorrow. An essential and proven product since 1960, these Maric Flow Control valves have been saving water and energy by controlling water flow and preventing waste. These valves will benefit you in industry, on the land, or at home. They are designed to deliver a constant flow of water when used on pressures varying between 15 and 150 pounds per square inch. Thus, only the quantity required is used. This assures enormous savings of water, energy, and of course, money. This illustration will show you how the Maric Flow Control valve operates. The valve consists of a precision machine body in either brass, PVC, stainless steel or other specified material which houses a flexible control ring. The arrow indicates direction of water flow. The flexible control ring rolls down the tapered seat as water pressure increases, reducing the size of its own orifice, thus giving it a constant flow rate. The control ring rolls back up the tapered seat as pressure is reduced. The flexing of the control ring during operation helps prevent the build-up of rust flakes, as this demonstration shows, helping to make the valve self-cleaning. We would like to take this opportunity to show you how we maintain our high standards during the manufacture of Maric Flow Control valves. These flexible control rings are the heart of the valve. They are manufactured from nitrile butadiene rubber, which is odor-free, taste-free, non-toxic, is unaffected by water or oil and many other liquids, and has a life in excess of 10 years under normal operating conditions. Compounding this material is an exacting process. It assures quality and durability and is carried out in a rubber mill, which we shall now see in action. The carefully weighed rubber is being fed into the mill. Adding this ingredient will show the thorough mixing action of the mill. Carbon, another of the many essential ingredients, is being added. Cutting and blending after each ingredient is added helps give uniform and thorough mixing. Every mix is numbered. Sample control rings are cured, aged, tested, catalogued and stored for future reference. The compounded rubber is later loaded into dies that are placed into these curing presses. They apply heat and pressure which molds, cures and transforms the material into Maric flexible control rings. Curing times and temperatures are critical. Curing cannot be rushed or vital properties will be lost. Hot dies are being removed from curing presses. Number 25 series control rings are removed from this die. All control rings are thoroughly inspected and faulty rings rejected. All visually perfect rings are then heat aged to stabilize them before undergoing flow tests. This is the first operation in the machining of a half-inch female-male brass valve body. Precision machine bodies are essential for the accurate operation of Maric Flow Control valves. All control rings are tested for accuracy on this test board. They are placed into holders with internal dimensions identical to valve bodies and are clamped into position. Water flowing through control rings under test lifts water in these columns, which indicates percentage variations above and below the rated flows. Control rings are then subjected to water pressures between 15 and 150 pounds per square inch or 100 and 1,000 kilopascals. Precision control rings must give flow readings within plus or minus 10% of rated flow over this pressure range. They must pass this test twice, firstly after curing and aging, and again immediately prior to sale. At 15 pounds per square inch, we see flow to be within tolerance. At peak flow of approximately 60 pounds per square inch, the flow is still within tolerance. Again, at 150 pounds per square inch, the flow remains within the 10% tolerance. These two control rings have passed their tests and are classified as precision. Control rings which test within plus or minus 15% of rated flow are classified as standard. Control rings outside this tolerance are completely rejected. Here we see a control ring being fitted into the precision machined recess of a number 25 series insert flow control valve. We now show Maric Flow Control valves in operation. This display consists of a pressure control tap, pressure gauge, shower rose, two Maric Flow Control taps, a manually restricted tap, a normal uncontrolled tap, and a drinking fountain. Water pressure is adjusted to 150 pounds per square inch. This tap has a 4.5 litre per minute or 1 gallon per minute Qui-Flow control valve fitted immediately behind the tap. Note small pressure drop when turned fully on. This tap has a 4.5 litre per minute precision control valve similarly fitted. Note again the small pressure drop. This tap is fitted with a manually adjusted restrictor which we now adjust to 4.5 litres per minute. Once again, a small pressure drop. On opening this uncontrolled tap only half a turn, notice the large flow and big pressure drop in the system. Note also the reduced flow from manually restricted tap. Note particularly the unaffected flow from the two Maric Flow Control taps. Big savings in water and money are possible if Maric Flow controlled valves are fitted to all household taps. Water pressure is readjusted to 150 pounds per square inch. The uncontrolled and manually restricted taps are adjusted to 4.5 litres per minute. Note the greatly reduced flow from these two taps when water pressure is reduced to 15 pounds per square inch. Again, note the unaffected flow from the two Maric controlled taps. Water pressure is held at 15 pounds per square inch, while uncontrolled and manually restricted taps are adjusted to 4.5 litres per minute. Observe the increased flow from these two taps when pressure is increased to 100 pounds per square inch. The two Maric controlled taps remain unaltered. The stream from a drinking fountain is greatly affected by varying water pressures, as is demonstrated. When this bypass tap is closed, all water to the fountain must pass through a 1.2 litre per minute flow control valve. See how little the flow changes with the same varying water pressures. Big savings of heating energy and water are possible when Maric Flow control valves are fitted behind the shower heads. This particular rose is also fitted with a 4.5 litre per minute control valve, which is ample water for showering. A large majority of roses use 18 or more litres of water per minute. You will notice that the flow varies little over wide pressure variations. This prevents a great deal of annoyance and perhaps burnt backs when other taps in the house are used. By using Maric Flow control valves, a 75% saving of costly hot water and a 50% saving of cold water can be obtained. By evenly distributing water, Maric Flow control valves save water in irrigation. We have set up two identical dome head sprinklers, one near ground level, the other 21 feet above. Both are connected to the one water line. At 15 pounds per square inch, the bottom sprinkler is operating satisfactorily, but very little water is flowing from the top sprinkler. The water pressure is increased to 28 pounds per square inch. The top sprinkler is now working correctly at 6¼ litres per minute, but now the bottom sprinkler is overloaded and is using 12 litres per minute. Fitting a 6¼ litre per minute control valve to the bottom sprinkler rectifies this, and now both sprinklers are operating correctly, but only at this water pressure and sprinkler elevation. If water pressure is increased to 50 pounds per square inch, the top sprinkler now becomes overloaded. It is fogging badly and is using 15 litres of water per minute. Fitting another 6¼ litres per minute control valve to the top sprinkler rectifies this, and now both sprinklers are operating as designed. Any further pressure variations up to 150 pounds per square inch will have no effect on output from either of these two sprinklers. With Maric Flow Control valves fitted to sprinklers, hillsides are no longer a problem. Water is no longer wasted, and even distribution of water is assured, and equally important, money is saved. School taps are an ideal and necessary place to install Maric Flow Control valves. Our flow control valves have been saving water for 12 years in the secondary school at Jepps Cross, South Australia. Multi-storey buildings invariably have water feed tanks installed on the roof in order to supply water to all outlets on all floors. Outlets on the top floor will have low pressures and low flows, while outlets on lower floors will have higher pressures and higher flows. To help even up these flows, a complicated system of pipe sizes and reducing valves must be designed. However, this cannot assure an even flow to all outlets because the number of taps that are being used at any one time will vary. Installing Maric Flow Control valves on all outlets will reduce pipe sizes, eliminate pressure-reducing valves, and give an even predetermined flow of water to all outlets. The paying customer on the top floor can now have the quantity of water that he requires when he wants it. So can the chef working on a lower floor and anyone else, anywhere in the building, who wants water at any time. The potential and importance of Maric Flow Control valves in industry is virtually unlimited. Here we see one of our valves in use in the textile industry at Actil cotton mills. The petrochemical industry also use our valves, as we see in this Shell tanker terminal in the United Kingdom. Our valves control the flow of water through these ultraviolet water purifiers in this Coca-Cola factory in Australia. They are also used in these Australian-made tube-light water purifiers. To safeguard health, bacteria in water must be destroyed. A Maric Flow Control valve controls the flow of water as it passes along this ultraviolet lamp. Too fast a flow, bacteria will survive. Too slow a flow, purifying costs will rise. Fitted with Maric Flow Control valves, they will operate correctly and safely, high in a hospital or at sea level in a fish processing plant. If you want to be sure that all your hotel showers get the correct amount of hot and cold water, no matter how many are in use at the same time or on any level, or if you want to irrigate all your plants with the correct amount of water, regardless if they're at the top or bottom of a hill, or reduce waste from your household taps, or conserve water in industry, the Maric Flow Control valve is the inexpensive and reliable answer. A Maric Flow Control valve is the simple, accurate way to get the quantity of water that you require when you want it, regardless of changing water pressures. Our flow control valves are economical, as the low cost is quickly recovered by the water and energy savings. Water is rapidly becoming more and more expensive. Start saving today by installing Maric Flow Control valves chosen from our extensive range of flows and bodies.